In this module, we learned a lot about pipes, what they are, how to use them, how to parameterize them, how to chain them, how to create our own pipes, and how to maybe create an impure pipe forcing update on each data change. Now there's one built-in pipe I want to have a closer look at which does something different than all the other pipes. It helps us with handling asynchronous data. And to demonstrate how this works, let's say we have another property right here at the top which says app status, or which holds our app status, which could also be offline, critical, whatever. But here, this will not be a string like offline. Instead, this should get loaded after, let's say, 2 seconds. And to simulate this, I will set this equal to a promise. And you can imagine this data being returned from a HTTP call, from a server, something like this. So in this promise, I will initialize this promise with a callback method passed to the constructor, where this method itself takes 2 arguments, resolve and reject, the 2 functions we can execute inside of this promise to resolve or reject the promise. And in the promise, in this callback function, I will then set up a timeout. Let's say it triggers after 2 seconds, so after 2000 milliseconds. And then this method here will get executed, this method I passed to the setTimeout method. Now here in this function, I want to simply set my app status. So I want to resolve to, let's say, stable, whatever the status should be. So what this will do is it will set app status to stable, but only after 2 seconds. So if we try to output this app status here, let's add a line break or another line break to have a blank line in between, and then a heading where I say app status, and then I try to output app status with string interpolation. If we do this, you see object. And this is correct because it is an object. It's a promise, and a promise is an object. But after 2 seconds, we know that this is no longer an object. It now is a string. But Angular doesn't know, because it doesn't watch our object. It doesn't see if this object actually transforms to something else or if this returns as a value. It just knows it's a promise, I'm done. And it's good that it behaves like this, saves us performance. We should be explicit about how our app behaves. But thankfully, there is a nice little pipe we can use here to make the transformation of this data easier. We know that it will be a string after 2 seconds, and we want to output this string. Or it will resolve a string after 2 seconds, I should say. And we want to output this string. So we can add the pipe symbol and then async. This is a built-in pipe, and by adding it, well, watch for yourself. You see, I will reload the app. There's nothing there at the beginning, but after 2 seconds, you see stable. And this is what async does. It recognizes that this is a promise, and as a side note, it would also work with observables. There it would subscribe automatically. And after 2 seconds, it will simply recognize that something changed, that the promise resolved, or in the case of an observable, that data was sent through the subscription, and it will print this data to the screen. And this is the pipe with which I want to conclude this section about pipes. Now you should feel really comfortable about using them, building your own pipes, and as you see here, working with async data with pipes. Now we will see this async pipe being used in the HTTP section later, but for now, let's move on to some exercises regarding pipes. One important note at this point, my IDE changed slightly here. The only reason for that is that I switched the IDE because I had to re-record these modules where you see the new IDE, which does not mean that the other modules are old or outdated. It just means these modules here needed an update to be up to the quality standards I want to enforce and to teach you the latest of Angular. If you see videos with a different IDE, then these videos still are perfectly fine. That's the only reason for that change. I hope it's no big problem. The project, of course, is exactly the same. The folder structure is exactly the same. You'll only have some tiny visual changes. Thus far in our application, we always worked in the browser only. That means that we control all our data with Angular, we store our data somewhere in memory in the browser, and it also means that whenever we restart the application, all our data is gone. It also means that we can't persist data anywhere. And of course, a typical requirement of an application you're building would be that the front end, so the part that runs in the browser, which is your Angular app, that this does not work standalone, but that it is able to communicate to some server, to store data there, to fetch data from there, to do whatever you need to do in your application. And that is exactly what we'll have a look at in this module. We'll learn how Angular communicates with a backend, with a database, and so on. You'll learn how to send HTTP requests and also how to transform data if you need to. You might remember that observables section where I gave you a first introduction to that. Now we'll take a closer look. So how does Angular connect to a database, or how do you connect Angular to a database in your application? Well, of course, it is a use case that you will often have. In your Angular app, you generate data like posts or recipes or whatever you have in your application, and you want to store that data in a database and also fetch it from there when your app restarts, when a user revisits your page, and so on. And it doesn't matter which kind of database we're talking about, if that's a SQL or no SQL database. Doesn't really matter. The thing is, you don't connect Angular to a database directly. That means you don't enter your database credentials into your Angular app or anything like that. This would be highly insecure because everyone can read your Angular code. Since it's a front-end JavaScript application, everyone can inspect the code there. And that is fine, but that also means you must not store credentials in there, for example. And you will learn how you can still authenticate users and so on later in the authentication section, but you definitely don't want to store database credentials. For more information on how secure your JavaScript code is, you can have a look at an article in a video I attached to this video here. So if we don't connect directly to a database, what else can we do then? Because we certainly don't want to have our standalone, independent, unconnected Angular app. Well, you send HTTP requests and you get HTTP responses to and from a server. A server, in the end, is defined as an API here. That means it is, for example, a REST API or a GraphQL API you are communicating with. And in this course, we'll use a REST API, which is the most common form of API you work with. Now, such a API, in the end, is almost like a normal website, but when you visit its URLs, you're not getting back HTML, but you're getting back data, mostly in the JSON format. And if you want to learn more about REST APIs in general, you'll also find some helpful resources related to that attached to this video. And I have a whole course, my Node.js course, where I also teach you how to create such APIs. Because you don't use Angular for the creation of these APIs, you use server-side languages like Node.js or PHP instead, but you can communicate with these APIs with Angular. And on that server, you then can have code that does interact with a database to store and fetch data. And of course, there are more reasons for communicating with a server than for storing or fetching data. It's not just about database access. You could be uploading files, or you could be sending some analytics to a backend, or any other reason for why you might need to talk to some backend server. Now, in this module, we will not write such a backend from scratch, since this is way beyond the scope of the course and totally not Angular's job. But I will show you how to use a free dummy backend, which could of course be replaced by any real backend you have, to send requests, to use responses, and so on. Before we start sending requests, it's important to understand the anatomy of an HTTP request. Because a HTTP request is made up of a couple of core parts, which we'll all have a look at in this module here when it comes to configuring them when sending a request. The most important part about a request, of course, is the URL you're sending the request to. That's also called the API endpoint. And it is something like yourdomain.com/posts/1, for example. The exact path here, of course, depends on the API you're interacting with. However, when communicating with a RESTful API, it's not just about the URL, but also about the HTTP verb you're using. Something like post, get, put. This defines which kind of request you want to send to that endpoint. Do you want to store new data? Do you want to fetch data? Do you want to replace existing data? The HTTP verb makes that clear. But it always depends on the API you're working with, which endpoints and which verbs for these endpoints are available. So the official docs for the API is always the place to go, unless you're, of course, writing your own API, in which case you, of course, know which endpoint supports which operations. Now, when we're sending a request, it's nice to know where and how to send it to that place, but you often also need to set additional metadata, the so-called headers of a request. Now, these are kind of optional, or to be precise, some default headers will be appended to a request for you by the browser and by Angular, but you can also append your own headers, and that is therefore also something we'll have a look at. Now, last but not least, for some HTTP verbs, you can also add a body to your request. That's the core data that is attached to a request. For example, if you're sending a post request to create a new piece of data on the server, well, then of course you should attach the information about that piece of data to your request, and you would do that in the request body. Therefore, a request body can be set on post, put, and patch requests, which are requests that do alter data on the server by adding or replacing it. Now that's the general anatomy of a HTTP request. Let's now have a look at how Angular helps us with writing or with creating such requests, how we can work with them, how we can work with the response, and what else Angular has to offer. Now let's dive into using Angular's HTTP features. And for that we need a backend. Now, as I mentioned before, we'll not write our own server-side solution here, because you would do that with a server-side language and not with Angular, and therefore this is of course not the scope of this course. By the way, if you want to see how to build a complete Angular frontend and a custom backend, my mean course, which you also find here on Udemy or on my page, academind.com, is a great place to go. But here, we'll simply use Firebase. Firebase sounds like it's a database only. Instead, it's a whole backend solution which gives us a REST API as well. And it's a perfect solution for this course and this module because it's free to get started with, and we can send requests there. We can send different types of requests. We can easily see the changes we make through these requests, and we can store data there, and therefore it's perfect. Now, you need a Google account for that. Once you got that, you can go to the console on firebase.com. And there, simply click on Add Project. Now give that project any name you want. And you can leave the other default settings and then check both check marks here. Now this will create a new Firebase project for you. And again, getting started here is free. You can of course check the pricing pages of Firebase to learn what else you can use for free and when it would start cost money. Now, once this is loaded, you'll see an interface that looks something like this. And here we'll go to database. Now again, Firebase is not just a database. It's a complete backend solution that also offers a database, but it's not just a database. It's not an alternative to MongoDB or anything like that. It's more than a database. It's a complete backend service. Now here, we'll not use Cloud Firestore, but instead, if you scroll down, we'll use that real-time database. It's a bit easier to use and gives us a nicer visual feedback. So click on Create Database here, and important, start in test mode. That's important. Later, we will add authentication, but for now, we'll use that test mode to be able to send requests and work with data without being restricted. Normally, you are, of course, protecting against unwanted access. Here, we are temporarily disabling this so that we can interact with that without issues. Now, and that is our basic setup we'll need. The URL you see here will already be the URL you can send requests to. So let's do that, and let's make sure that we now use that to store data by sending a post request.